We are using dilute HCl solution here. So similarly, in order to activate the anion exchange resin, we are using alkaline regenerator. So this alkaline regenerator generally, so what we are using as alkaline regenerator, that is dilute sodium hydroxide. So dilute sodium hydroxide we are using as alkaline regenerator. So by using these regenerators, we can reactivate the resin. So for further activate for further working process. So this is about ion exchange unit. And next here, these are the reactions which involved in the ion exchange chambers. So generally in the cation exchange chamber, so this is the reaction. So where the cations are replaced by the cation exchange resin. So for example, the cation, if you take calcium or magnesium cations, those are replaced by H plus ions by the ion exchange resin. So finally we'll get the, so this one is the H plus ions, and here we'll get the means calcium involving or magnesium involving resins here. So this is the cation exchange resin, so which is replaced by the calcium or magnesium ions. So these two reactions are happening at cation exchange chamber. And what about the anion exchange chamber? So here the anion exchange chamber, so all the anions so that are present in the hard water like sulfates, chlorides. So these anions can be replaced here in the anion exchange chamber. So that anionic exchange resin generally it is having ROH, means OH here is the responsible group for the exchanging of the ions. So this OH group exchanging in the so here it is involving in the exchanging of anion from the hard water. So thereby after exchanging, so we'll get OH minus ions here. So these are the two reactions that are happening at the cationic exchange chamber and anionic exchanging chamber. And after the exchange of all these ions, so the H plus ions which are available at the cation exchange chamber and the OH minus ions which are available at the anion exchange chamber, they combine together, they form water molecule here. And this water is free of all ions and free of all salts. So this water is known as demineralized water and deionized water. And next, so regeneration, as I explained earlier, so these are the reactions involving in the regeneration process. So here, in order to regenerate the cation exchange resin, we are using dilute HCl, right? So that dilute HCl, how it reacts with the how it reacts with the used ionic exchange resin. So see here, this is the used cation exchange resin. So after the exchange of the cation, so this is the form of the ionic exchange resin. So now this cation exchange resin is activated by dilute HCl solution. So after the regeneration, you will get the means initial ionic exchange resin, that is cationic exchange resin. So RH plus you will get here. And here during the anion exchange resin, so the used anionic exchange resin is now it is treated with dilute NaOH solution. So where it reacts with the NaOH solution, and now the sulfate ions or the chloride ions, so what they occupied in the ionic exchange resin, so they replaced by the OH minus ions, and finally we'll get the ROH, means that is the general formula of the anionic exchange resin. So our anionic exchange resin is regenerated now. So these two resins, so we can use for further purpose or further working process. So we can use the cation or anionic exchange resins. And here, so let me tell you the advantages of the ion exchange process. So with the help of ion exchange process, so we can treat any highly acidic water or highly alkaline water also we can treat with the help of ion exchange process. And as I said earlier, so this is the very best method to remove the hardness of the water. So with the help of ion exchange process, so we can reduce the hardness till 1 to 2 ppm. So means very low hardness water we'll get during this process. And what are the disadvantages of the ion exchange process? So here the setup, the ion exchange process setup is very costly. And next, so if you use any turbid water for the treatment purpose, so we cannot get the much pure water, so because of this ion exchange process. So these are the two limitations or drawbacks of the ion exchange process. Yes, thank you all.